Find the interval of convergence for the power series, the summation n equals 1 to infinity of 3n factorial times x minus 3 to the n, all divided by 3 to the n. We're going to use the ratio test, where we divide successive terms. Replace n by n plus 1, and to get to the heart of the matter, what we'll do is create 3 separate fractions, one for each term. When we replace n by n plus 1, we actually end up with 3n plus 3 factorial. Second fraction will be in the denominator here, 3 to the n plus 1. The third fraction will be x minus 3 to the n plus 1. In the gaps, we'll put the terms that come from a sub n. When you divide by a fraction, you can multiply by the reciprocal. That would flip who's in the numerator, who's in the denominator. And that's how we end up with a 3n factorial in the denominator. We put it underneath the first fraction, 3 to the n in the numerator, above this, the 3 to the n plus 1, and then we have x minus 3 to the n below the x minus 3 to the n plus 1. And then we need to algebraically manipulate this by taking the exponents and decomposing them. And then with the factorial, it's like having 8 factorial as 8, 7, 6, and then all the rest of the written as 5 factorial. We have to take off 3 terms. We have to take off a 3n plus 3, a 3n plus 2, and a 3n plus 1 before we're left with 3n factorial. 3 to the n plus 1 becomes 3 to the n times 3. X minus 3 to the n plus 1 becomes x minus 3 to the n times x minus 3 to the 1, so that we can cancel. Well, then what are we left with? The 3n plus 3, the 3n plus 1 times 3n plus 2. We're left with the 3 in the denominator and an x minus 3. But n's getting large. No matter what x is, the denominator's 3, but the numerator is going off to infinity. There's no x that will turn this thing and make it less than 1 for convergence. The limit is infinite, which is never less than 1. Always greater than 1, no matter what x is. And so it seems like we always get divergence, but we must remember that there is one value of x that you can always guarantee convergence for. That's when x is equal to a, your center value. You see, when x is 3 here, no matter what these coefficients are, 3 minus 3 is 0. You have a bunch of zeros. So you can always guarantee convergence at the center. So that's, we get convergence, but we only get it there only at x equals 3. At that point only. And no other values. And one way to write that is just as a set with the number 3 in it. Divergent except for when x is equal to 3. And we say our answer is the set with the number 3 in it. A singleton set. A set with just the number 3 in it. That's the only place it converges at.